In today's video, we'll be learning about solving integrals with U substitution. To solve integrals with U substitution, we'll first write down an integral that requires U substitution. So, we're going to be taking the integral of 3x plus 4 raised to the 6th power, and this requires U substitution. Now, in this case, we'd have to make 3x plus 4 U, and I'll explain why later. So, when we make something U, we put U is equal to that expression, so 3x plus 4. Now we take the derivative of both sides, and this is a required step. Now, why are we taking the derivative of both sides? Because we want the integral to be in terms of U, and I'll show you how it will be in terms of U after we write it. Okay, and it's just 3 dx because the derivative of 3x is just 3, derivative of 4 is just 0. And then we can rewrite this as du is equal to dx, and then we're done for writing the du. Now we can rewrite this whole integral as u raised to the 6th power, okay, du over 3. And we can write du over 3 because we're just replacing dx with du over 3. And we can do that because of this equation right here. Okay? Now, we can actually write this even more according to our integral rules by putting the 1/3 outside the integral. So now it became even more simpler. And as you can see here, you can begin to understand why we made 3x plus 4u. It's because when you take the derivative of 3x plus 4, it will become a constant. So, what does that mean? That means that when we do that, it will become a constant, and then constants and integrals, we can put them on the outside, so we don't have to worry about integrating the constant also. However, if we made, let's say like a value, right, that's x squared, okay, and then you took the derivative of that, it would be 2x, and there was no, and then as a result of doing that, there was no way for 2x to cancel. Now you just ran into an error because you would have to find out for some way for that 2x to be cancelled out and turned into integrated again. So you have to watch out, okay, because for what you make u, because sometimes whenever you make u, that can turn into another problem for yourself, which is not what we want. We want to make, the whole goal of U substitution is to make the integral more simpler for you to solve. So that's why you make 1/3 3x plus 4u, because it turns into a constant. Okay, now we can actually solve this even more, right? The integral of u to the 6th power, what is that? It's just (1/7) times u to the 7th. Okay, and this is our answer in terms of u. In terms of u, how do you put it in terms of x? Well, replace u with 3x plus 4, and we're done. So 1/3 times 1/7, 21, and then 3x plus 4 to the 7th power, and we're done. That's our answer. However, also plus c right there. That's our answer. Forgot the plus c there. Yeah, the plus c. And also one more thing, don't ever forget the plus c. Very important. And it's only important in indefinite integrals, as I made clear in another video. And never forget the plus c. Let's do another example. Now, in this case, you want to make u x squared plus 4. Now, why do you want to do that? Well, when we do that, right, not only will x squared, not only can we replace x squared plus 4 with u, but when we take the derivative of x squared plus 4, it will become 2x. And then this 2x right here, we can cancel out, and it will become 1. And I'll show you what I mean. So again, it's just all about cancel out terms and making the integral more simpler so that it's easier to solve. And then after that, you want to substitute u back in for the answer. Okay, so that, and then 2x over u, right? Because u is x squared plus 4. And then du over 2x. Now we have a unique thing here. We can cancel out 2x, right? 2x here. So then we can rewrite the integral as the integral of 1 over u du. See, look how simple it became. Look, we really rewrote this integral here to this. So now it's way easier to solve. So that's actually the specialty of U substitution. You can really condense a integral to make it easier to solve. Now this is just simple, right? What is the integral of 1 over u? Well, according to integral rules, it's just ln of the absolute value of u plus c. So this is our answer in terms of u, and then for our answer in terms of x, we just plug in u. So ln, the absolute value of u plus 4, and then plus c, natural log of the absolute value of x plus 4 plus c. Now we actually don't even need this absolute value sign here, because if you plug in negative numbers into the x squared, or even positive numbers, it'll anyway be positive, right? So absolute value sign is not really needed there, but if you want, you can keep it there. Okay, now I'll give you a harder problem, and this problem will require trig. So yeah, okay. So take a moment to solve this problem, and I'll get back to you after you're done. So secant x squared times tan x. Okay, that's the problem. So take a moment and try to solve this problem here. Pause the video. Okay, now that I've taken a shot, I'll solve it now. So in this case, right, we know that the derivative of tangent x will be secant x. So that actually gives us like such a advantage, because we know that we can make u tan x, right? So then tan x will be converted to u, and then we can also cancel out the secant x. Okay, so it looks something like this. U is equal to tan x, du is equal to secant x squared. Alright, I meant secant x squared, not secant x. And then we can put dx is equal to du over secant x squared. And then now we can cancel out the secant x squared. Okay, so it looks something like this. So secant x squared, I'll just rewrite it for now, times u, right? Tangent x has been u converted to u now from this equation right here, times du over secant x. So now we can cancel out secant x, and the equation will be this now. See, look how simple this became. We went from this equation here, this integral to here. Wow, like look, that's really amazing, because we had this kind of hard-looking integral problem, and we just condensed it into a very easy problem. Literally, u, the integral of u, which is easy to do because that's just 1/2 times u to the second power. So 1/2 times u to the second power plus c, and that's our integral in terms of u. In terms of x, again, I'll just rewrite it. Actually, I'll just rewrite it in the same place for organizational purposes. terms of x, we just replace the u, right, with 10x, so 10x, 10x squared plus c. And that's our answer. So as you can see here, U substitution is a very, very, very important method to solving integrals. And it can actually really help you when you're stuck and don't really know how to solve an integral. Alright, that was solving integrals with U substitution, and I'll see you in the next video.